Okay, so now this is the next circuit. So for this one, this is your circuit, the one that you have to find information about. Those are all the resistors, the resistances of every single one of those resistors expressed. Your job, of course, is to fill in the table. Those colors here tell you exactly where the current is going. Current red means that those resistors with crossed by the same current are in series. As you see, only R5 is there. There's nothing else that the red current is crossing. R1 is alone, okay, because it's crossed by the current green. Then you have this current here branching off into the orange and the blue, purple, whatever this is. So the only thing you can say at this point is that R2 and R3 are connected by a parallel connection because both of them have exactly the same potential. But at this point, okay, what you can say is since the 2 and 3 have the same connection in parallel, then you can calculate the equivalent resistance for 2, 3. Remember, the first job is for you to calculate the equivalent resistance. So at this point, the R23 is calculated as follows. And 1.43 ohms is this value here. Now again, follow the current. You can see that those two resistors are both of them crossed by the same current, which means they are connected in series. Therefore, you will add those two values together, and this is the number that you will get. Once you have your equivalent resistance in this branch, then you will realize, going back, that this is the other resistor that you have, which is connected in parallel with the 5.43. At that point, calculate the parallel of those two resistors, and this is the number. And you will add also the last value, which is connected in series. At that point, your equivalent resistance is going to be 293. From now on, from this point on, you can now calculate your equivalent current as V over the R equivalent. So at this point, you will find that your I equivalent is given by 4.096 amps. With this value, you know this value here. So at this point, your next track will be to go back to this picture and mark down which current you were talking about. So this is your 4.096, which as you can see is red, so this means that it's crossing the R5. So this is also where you're going to put 4.096, which will give you the value V5, which is multiplied by 1 is still 4.096. So now those are the volts that you have over here. At this point, what would you do? You know this value of voltage because you know this drop, because the V5 is this value right here. So this means that your V1, right, V1 is equal to 12 volts minus the V5. So this means that you have a 7.91 for this value here, which again, when you divide the value of V by R, you have a value of 2.64 for the current, which is this one, which is the green current. So 2.64 is right there, which means also that you will know which current is going here on this branch and this branch, because it's going to be the 4096 minus the 264. 4096 minus 264, that will give you a 1.5, let's say. Those are the amps going on here. So this is your I4 also. So 46 is really the value, let's say. So this is 1.46, which is the value there, which will give you, when you multiply those two values, will give you the 5.8, which is the drop here. Drop here means that this branch is going to fill a value of V2, which is 12 minus the V5 minus the V4, which will give you 2.11, with which, according to the table, you will find the current of 1.06. At that point, V3 is going to have exactly the same voltage as V2. So V3 is also 2.11, and you will calculate I3, which is 0.42. And you're done.